If you were to stand in a universe that was truly infinite, eternal, and filled uniformly with stars, the night sky would not be dark. In such a place, every single point of the celestial sphere would eventually lead your eye to the surface of a star. The darkness we see above us is not a given. It is an impossibility under those specific conditions. For centuries, this simple observation has served as one of the most profound contradictions in cosmology. We assume that the blackness of space is the natural state of things, but when analyzed through the lens of geometry and light, that darkness becomes a clue. The night sky should be blindingly bright. To understand why we perceive a void, we must first strip away the distractions of our immediate environment. Imagine moving far beyond the reach of city lights and the orange haze of human civilization. Move further still, leaving behind the thin veil of the Earth's atmosphere that scatters sunlight during the day and glows faintly at night. In this purified state, you are left with a vacuum. You are floating in a space where there is no air to block your view and no local glow to obscure the depths. You look up and see a velvet blackness punctuated by a few thousand points of light. This darkness feels intuitive. It feels like emptiness. But if the universe were as we once imagined it, infinite in extent and unchanging in age, this void would be filled with an impenetrable wall of fire. This contradiction is known as Olbers' paradox. In 1823, Heinrich Olbers brought this problem into sharp focus, though the question had been pondered by thinkers long before him. The paradox arises from a set of assumptions that seem reasonable on the surface, but lead to a terrifying conclusion. First, it assumes that the universe is static, meaning it is not expanding or contracting. Second, it assumes the universe is eternal, having existed forever without a beginning. Third, it assumes that stars are distributed uniformly throughout this infinite space. In this idealized model, no matter which direction you look, your line of sight must eventually intersect with a star. Think of it like standing in a forest of infinite size and infinite density. If the trees are spaced evenly and the forest goes on forever in every direction, there is no gap through which you can see the horizon. Eventually, your gaze will hit a tree trunk. The universe, in the classical paradox, is that forest. Instead of trees, the space is filled with stars. Because the universe is infinite in this model, there is no edge and no empty void large enough to provide a window of darkness. Every single line of sight, regardless of how slightly it deviates from another, must eventually terminate on the glowing surface of some distant sun. If every direction ends in a star, then the entire sky should be as bright as the surface of a typical star. The night would not exist. There would be no constellations and no black gaps between the stars. Instead, the heavens would be a solid, seamless sheet of light, radiating an intense heat and brilliance from every single coordinate of the sphere surrounding the Earth. This is the logical conclusion of a static, eternal, and uniform universe. Yet, when we step outside on a clear night, we find the opposite. We find a darkness so deep it feels absolute. To resolve this, one might initially assume that distance is the answer. It seems intuitive that as a star gets farther away, its light becomes dimmer, eventually fading into nothingness before it can illuminate the sky. This is based on the inverse square law of light. If you double the distance to a star, the amount of light reaching your eye drops to 1/4 of its original intensity. As the distance increases toward infinity, the brightness of any single star approaches zero. It would seem that distant stars simply vanish into the dark. However, geometry creates a counterintuitive balance. While an individual star becomes dimmer as it moves farther away, the volume of space containing other stars increases. Imagine a series of concentric shells surrounding the Earth. The first shell is a thin sphere at a certain distance. It contains a specific number of stars. The second shell is twice as far away. Because the surface area of a sphere grows with the square of its radius, this second shell has 4 times the area of the first. If the stars are distributed uniformly, this second shell contains 4 times as many stars as the first. The math creates a perfect cancellation. The light from each individual star in that second shell is 4 times dimmer than the light from the first shell. But there are 4 times as many stars providing that light. The total amount of light reaching the observer from each successive shell remains constant. Whether you are looking at a nearby group of stars or a group a billion light-years away, the combined brightness contributed by that layer of space is exactly the same. As you add more and more shells, extending your gaze deeper into an infinite universe, you continue to add equal amounts of light to every point in the sky. The brightness does not fade, it accumulates. In this mathematical framework, distance alone cannot save us from the blinding light. The dimming effect of space is perfectly offset by the increasing number of stars. This means that if the universe were truly infinite and eternal, the darkness we see would be mathematically impossible. This realization forces us to question the very nature of our reality. If the math says the sky should be bright, but our eyes tell us it is dark, then one of the starting assumptions must be false. The paradox reveals that the universe cannot be all 3 things at once. It cannot be static, eternal, and uniformly filled with stars. One of these pillars must crumble. For a time, some suggested that cosmic dust might be the solution. The idea was that vast clouds of interstellar gas and dust act as a curtain, absorbing the light from the most distant stars before it can reach us. In this view, the darkness is not an absence of stars, but a result of occlusion. We are simply living in a foggy corner of a brilliant universe, shielded by a cosmic shroud. But this explanation fails when subjected to the laws of thermodynamics. Dust does not simply make light vanish, it absorbs energy. As these dust grains soak up the radiation from countless distant stars over an eternal amount of time, they would heat up. Eventually, the dust itself would reach a temperature where it begins to glow. In an eternal universe, the dust would become as hot and bright as the stars it was meant to hide. The sky would not be black. It would be a glowing, incandescent fog. The curtain would simply become another source of light. This leaves us in a position of profound cosmic tension. We are faced with a void that should not exist. Every logical path through a classical infinite universe leads back to a sky filled with fire. To find the answer, we have to stop thinking of the universe as a permanent fixture and start thinking of it as an event. We must move away from the idea of a static eternity and consider the possibility of a beginning. The darkness of the night is not a sign of emptiness, but a sign of limitation. It suggests that there is a boundary, not necessarily a physical wall in space, but a boundary in time. If the universe had a beginning, then light has only had a finite amount of time to travel. The reason every line of sight does not end in a star is that the light from the most distant stars simply has not had enough time to reach us yet. We are living in the window of time before the rest of the infinite forest has revealed itself. This transition in thinking changes everything. The blackness we see when we look up is actually a measurement of the age of the cosmos. It is a silent testament to the fact that the universe is not eternal. The darkness is a horizon, a limit imposed by the speed of light and the birth of time itself. When we gaze into the void, we are not looking at nothingness. We are looking at the distance that light has yet to traverse. The scale of this mystery is difficult to grasp because it requires us to move beyond our human experience of space. We are used to things being either there or not there, but in cosmology, something can exist and still be invisible to us simply because it is too far away for its history to have caught up with the present moment. The night sky is dark because the universe is young. Consider the implications of this limitation. If we could wait forever, would the sky eventually fill with light? In a static universe, perhaps. But our universe is not static. It is expanding, stretching the very fabric of space between galaxies. This expansion adds another layer to the resolution of the paradox, shifting the energy of the light and pushing the distant stars even further beyond our reach. But before we can dive into the mechanics of expansion, we must first fully accept the collapse of the eternal model. The classical paradox was a tool for demolition. It tore down the idea that the universe has always been here in its current form. By proving that an eternal static universe is incompatible with a dark night, Olbers' paradox paved the way for the modern understanding of the Big Bang. The darkness becomes a piece of evidence. In the same way that a detective uses a missing object to prove a crime took place, astronomers use the missing light of the night sky to prove that the universe had a starting point. The void is not an absence, it is a signature. It is the mark of a finite age written across the entire celestial sphere. As we drift further into this realization, the night sky begins to feel different. It is no longer a cold, empty vacuum. Instead, it is a map of time. Every dark patch between the stars is a region of space whose light is still on its way to us, or perhaps a region where the light has been stretched so thin that it has vanished from our sight. The darkness is the memory of the beginning, the echo of a moment when everything started from a single point and began its long, lonely journey outward. We are floating in a sea of light that is still unfolding. The reason we can sleep under a dark sky is because the universe is not an infinite, unchanging machine, but a growing, evolving entity. We are protected by the speed of light. We are shielded by the fact that the cosmos has a birthday. When you look at the stars now, try to see the gaps between them not as holes, but as distances. See the blackness as a physical thing, a distance of billions of years that light is still struggling to cross. The paradox is resolved not by finding more stars, but by accepting that we are limited in what we can see. Our observable universe is a bubble of light in an ocean of darkness, and the walls of that bubble are defined by the age of time itself. This realization brings us back to the scale of the mystery. We started with a simple question about why it is dark at night, and we ended up discovering that the universe has a history. The simplicity of the night sky hides a complexity that defies intuition. It tells us that we live in a cosmos that is finite in age, even if it is infinite in extent. The transition from the classical view to the modern one requires a shift in how we perceive light. We often think of light as something that just exists, filling a room or illuminating a landscape. But in the deep vacuum of space, light is a messenger. It carries information about where it came from and when it left. If the sky were bright, it would mean that the messengers from every corner of eternity had already arrived. The fact that they haven't tells us that the journey is still ongoing. This brings us to the concept of the particle horizon. There is a limit to how far we can see. Not because there is a wall of fog or a curtain of dust, but because light has a maximum speed. If the universe is 13.8 billion years old, then we can only see light that has traveled for 13.8 billion years. Anything beyond that horizon is effectively non-existent to us. It might be there, it might be teeming with stars and galaxies, but its light is still racing toward us across the expanding void. The darkness of the night sky is therefore a direct result of this cosmic speed limit. The shells of stars we imagined earlier do not go on forever in our experience. They stop at the edge of the observable universe. Beyond that point, the light has simply not had enough time to reach Earth. The sum of all starlight is finite, because the time available for that light to travel is finite. This resolution turns the terrifying scale of an infinite, blinding universe into something more manageable, yet still awe-inspiring. It replaces a wall of fire with a horizon of time. We are not trapped in a static, eternal cage of light. We are travelers in a dynamic, expanding story. The darkness is the canvas upon which the history of the universe is being painted, one photon at a time. As we contemplate this, we can begin to see the night sky as a living record. Every star we see is a survivor of that long journey. Every dark gap is a mystery waiting for its light to arrive. The paradox of Olbers is not just a mathematical puzzle. It is an invitation to look at the darkness and see it as evidence of our own origin. The void is where the answers hide. By understanding why the sky is dark, we understand that we are part of a process. We are not merely observers in a finished universe. We are witnesses to an ongoing expansion. The silence of the night is the sound of the universe growing, pushing galaxies apart and stretching the light of the ancient past into the deep red of the distant future. This brings us to the intersection of age and movement. It is not enough to say the universe had a beginning. We must also acknowledge that it has been changing since that moment. The expansion of space does more than just move galaxies away from each other. It alters the light itself. This process, known as redshift, ensures that even if there were an infinite number of stars, their light would eventually be stretched so much that it would shift out of the visible spectrum and into wavelengths we cannot see with our eyes. The darkness is therefore a combination of two great limits: the limit of time and the limit of energy. We cannot see everything because the universe isn't old enough for all the light to reach us. And we cannot see everything because the expansion of space is stealing the energy from the light that does arrive. Together, these forces create the velvet blackness that allows us to sleep, to dream, and to wonder. When you look up tonight, remember that the darkness is not empty. It is filled with the ghosts of stars whose light has been stretched into invisibility. It is filled with the potential of galaxies that are still racing toward our horizon. The night sky is a mirror reflecting the very nature of existence, a balance between the brilliant energy of stars and the vast, patient silence of the void. The classical paradox assumed a universe that was a finished product, a static painting where every detail was already in place. But we live in a universe that is more like a symphony, still playing its opening movements. The darkness is simply the part of the music we haven't heard yet. It is the space between the notes, providing the contrast that makes the light of the stars meaningful. Without the darkness, there would be no constellations. There would be no way to map the heavens or navigate the seas. The very structure of our curiosity depends on this void. We are driven to explore because there is something hidden in the blackness. The paradox of Olbers teaches us that the most important things about the universe are often found not in what we see, but in what is missing. As we drift deeper into the cosmic night, we can let go of the need for a filled sky. We can embrace the darkness as a protective layer, a reminder that we are small and that the universe is unimaginably large. The scale is terrifying, yes, but it is also liberating. It means there is always more to discover, always another horizon to reach, and always a deeper mystery waiting in the shadows. The night sky is dark because we are lucky enough to live in a universe that had a beginning. We are living in a window of time where the light is sparse enough for us to see individual stars, yet abundant enough to guide our way. This balance is the foundation of our astronomical history. It allowed early humans to track the seasons and modern scientists to calculate the age of the cosmos. The darkness is not an enemy of light, it is its companion. Light defines the shapes of galaxies, but the darkness defines the scale of the universe. Together, they tell a story of expansion, cooling, and time. The blackness above us is the ultimate evidence of the Big Bang, a silent confirmation that everything we know emerged from a single point of infinite density and has been traveling outward ever since. In this light, or lack thereof, the night sky becomes a sanctuary. It is a place where the mind can expand to match the scale of the void. We are floating on a small blue marble, surrounded by an ocean of darkness that stretches for billions of light years in every direction. And yet, within that darkness, we find our place. We find our history. The paradox is solved, but the wonder remains. The fact that the sky is dark is just as miraculous as the fact that it contains stars. It tells us that we are part of a cosmic timeline, moving from a hot, bright beginning toward a cold, dark future. For now, we exist in the middle, in the golden age of observation, where the night is dark enough to be peaceful and the stars are bright enough to be seen. As we settle into this thought, let the darkness wash over you. Let it be a blanket of cosmic proportions, shielding you from the noise of the world. The void is not empty. It is full of history. It is full of the distance that defines us. It is the space where the universe breathes and expands, creating room for everything that ever was and everything that will ever be. The journey from Olbers' question to our modern understanding is a journey from certainty to curiosity. We started with the certainty that an infinite universe should be bright, only to find that the reality of darkness is far more interesting. The void is where science meets philosophy, where mathematics meets mystery. It is the place where we realize that being small in a vast universe is not a tragedy, but a privilege. We are the eyes of the cosmos looking back at itself. When we look into the dark night sky and ask why it is black, we are really asking who we are and where we came from. The answer lies in the expansion of space, the speed of light, and the finite age of time. The darkness is our origin story, written in the absence of light. So, as you gaze upward, do not fear the void. Do not see it as a sign of loneliness or emptiness. See it as the horizon of possibility. See it as the evidence that we live in a universe that is still growing, still changing, and still unfolding. The night sky is dark because there is so much more yet to be revealed. The scale of the universe is indeed terrifying, but it is also a source of profound peace. In the face of such immensity, our daily worries fade into insignificance. We are tiny specks of consciousness floating in a vast, dark sea. But we are specks that can understand the math of the stars. We are small enough to be humbled, but large enough to comprehend. The darkness is our home. It is the backdrop against which every star shines and every galaxy spins. It is the silence that allows us to hear the whisper of the cosmic microwave background. It is the space that gives us room to exist. The paradox of Olbers reminds us that the most obvious things, like the blackness of a summer night, are often the deepest mysteries of all. We have moved from the idealized forest of stars to the reality of an expanding cosmos. We have seen how distance, time, and expansion work together to keep our nights dark and our horizons open. The universe is not a static painting. It is a living process, and we are part of that process, drifting through the darkness toward an unknown destination. The night sky remains a mystery, but it is a solvable one. It tells us that the universe has a beginning, that it is expanding, and that light is a finite resource. These truths provide the framework for everything we know about astronomy. They allow us to map the movement of galaxies and predict the fate of the stars. As you drift closer to sleep, imagine yourself floating away from the Earth, past the Moon, past the planets, and out into the deep interstellar void. Feel the cold, quiet embrace of the darkness. See the distant stars as tiny lanterns in an endless sea. Remember that this darkness is not a void, but a bridge connecting us to the very first moments of time. The scale is immense, but you are a part of it. The atoms in your body were forged in the hearts of those same stars that punctuate the night. You are made of the light and the darkness. You are a piece of the universe experiencing itself. And as you look out into the blackness, you are not looking away from home. You are looking directly at it. The paradox is gone, replaced by a deeper understanding. The sky is dark because the universe is a story that is still being told. We are currently in a chapter of light and shadow, where we can see enough to be curious, but not so much that we are blinded. It is the perfect environment for a thinking mind to wonder about its place in the infinite. Let the vastness settle around you. Let the silence of the void quiet your thoughts. The universe is large, and it is old, and it is expanding into an endless future. But here, in this moment, you are safe. You are held by the gravity of your world and shielded by the darkness of the night. The mystery of Olbers' paradox leads us to a place of stillness. It teaches us that the absence of something can be just as informative as its presence. The dark sky is a teacher, showing us the limits of our sight and the boundaries of our time. It invites us to stop searching for answers in the light and start finding them in the shadows. As we prepare to move deeper into the structures of the cosmos, let this darkness be your foundation. Let it be the quiet space where you can imagine the birth of galaxies and the collision of black holes. The void is not a barrier. It is a gateway. It is the open road that leads from our small planet to the farthest reaches of the observable universe. The night sky is dark, and in that darkness, we find the truth of our existence. We are children of a finite beginning, living in an expanding infinity. We are the observers of a cosmic dance that began billions of years ago and will continue long after we are gone. And in this realization, there is a profound sense of peace. The scale is terrifying, but the perspective is beautiful. To know that the darkness above us is evidence of the Big Bang is to know that we are part of something grander than any human imagination could conceive. We are not alone in the dark. We are surrounded by the history of everything that ever was. As you close your eyes, imagine the darkness not as a lack of light, but as a presence, a calm, neutral, and eternal presence that holds all the stars and galaxies in its embrace. The universe is vast, and it is silent, and it is waiting for us to discover its secrets. But for now, there is no need to search. There is only the need to be still. The night sky has told us its first secret, that it is dark because we are young. This simple truth opens the door to everything else: the expansion of space, the cooling of matter, and the slow drift of galaxies toward a distant horizon. The paradox is solved, and in its place, we find a universe that is dynamic, evolving, and infinitely mysterious. The darkness is our sanctuary. It is the velvet curtain that falls at the end of every day, allowing us to look past our own world and into the depths of eternity. It is the space where we can dream of other worlds and wonder about the nature of time. The night sky is dark, and that is exactly how it should be. In this stillness, we find the courage to face the scale of the cosmos. We realize that being small does not mean being insignificant. To be a small part of an infinite universe is to be a witness to the greatest story ever told. The darkness is simply the page on which that story is written. As you drift further into sleep, let the image of the dark sky remain with you, not as a void, but as a map of time, distance, and light. A map that leads back to the beginning of everything and forward into the endless future. The night is quiet, the stars are distant, and the universe is expanding in a slow, rhythmic pulse. The paradox has led us here, to this point of absolute calm. We have dismantled the old certainties and embraced the new mysteries. We have learned that the darkness is not an absence, but a revelation. It is the signature of a universe with a history, a beginning, and a destiny. Rest now in the knowledge that you are part of this vast design. You are a speck of stardust floating in a dark ocean, protected by the laws of physics and cradled by the silence of space. The night sky is dark, the stars are far, and everything is as it should be. If we assume a universe that is infinite in size and eternal in age, where stars are scattered evenly throughout every cubic inch of space, then the night sky should not be black. In such a world, no matter which direction you looked, your line of sight would eventually hit the surface of a star. The darkness we see would be replaced by a solid wall of light, as if we were standing in the middle of an endless forest, where every single gap between the trees is filled with another tree further back. This is the heart of Olbers' paradox. It suggests that our eyes should be overwhelmed by a blinding radiance coming from every coordinate of the celestial sphere. Yet, when we step outside on a clear night, we find a profound and heavy darkness, punctuated only by tiny, distant pinpricks of light. To solve this, early thinkers looked for physical barriers. One of the most intuitive suggestions was the presence of cosmic dust. The idea was simple. Perhaps the universe is indeed filled with stars, but vast clouds of interstellar gas and dust act as a veil, blocking the light from the most distant reaches of space before it can reach our eyes. It seems like a logical solution. We know that dust exists in our own galaxy. We see it in the dark nebulae that blot out the stars of the Milky Way. But when we apply this to an eternal and infinite universe, the dust solution collapses under its own physics. Dust does not simply delete light, it absorbs it. In a universe that has existed forever, these grains of dust would have been absorbing starlight for an eternity. They would heat up as they absorbed this energy, and eventually, they would reach a state of thermal equilibrium with the stars around them. Once the dust reached this temperature, it would begin to radiate that energy back into space as light itself. Instead of a black sky, we would see a glowing fog of infrared radiation filling every corner of the void. The sky would still be bright. It would just be a different color of brightness. Dust can hide a star, but it cannot hide an infinite amount of energy in a closed system over an infinite amount of time. This realization forces us to move away from the idea of a static, eternal universe and toward a reality defined by limits. The first limit is the lifespan of the stars themselves. We often think of stars as eternal beacons, but they are biological entities of a sort, born from clouds of gas and destined to die. A star has a finite amount of fuel. Once its core runs out of hydrogen to fuse into helium, it collapses or explodes, leaving behind a remnant like a white dwarf, a neutron star, or a black hole. No star lasts forever. Even the smallest red dwarfs, which can burn for trillions of years, eventually flicker out. In an infinite universe that has existed for an eternity, every single star would have already exhausted its fuel and gone dark long ago. the cosmos would be a graveyard of cold cinders. But we see stars burning brightly around us today. This tells us that the stars we observe are relatively young in the grand scale of time. There simply hasn't been enough time for every part of the universe to ignite, and there is not enough fuel in any one region to keep the sky glowing forever. The luminosity of the universe is a flickering candle, not a permanent floodlight. This leads us to a more fundamental limit: the age of the universe itself. We now know that our observable universe is approximately 13.8 billion years old. This number is not just a date in a history book, it is a physical boundary. Light travels at a constant speed, roughly 300,000 kilometers per second. While this seems unimaginably fast, on a cosmic scale, it is agonizingly slow. If the universe began 13.8 billion years ago, then light from an object more than 13.8 billion light-years away simply hasn't had enough time to reach us yet. There are regions of space that exist, perhaps filled with trillions of stars and galaxies, but they are invisible to us because their light is still in transit. We are encased in a bubble of visibility called the particle horizon. This horizon defines the edge of the observable universe. Beyond this boundary, the universe may go on forever, or it may curve back on itself. But for all practical purposes, that region does not exist in our current reality because no information from it has ever touched our skin or entered our telescopes. The night sky is dark, partly because we are living in a universe that had a beginning. We are seeing only the light that has managed to cross the distance within the time allotted since the Big Bang. If we waited another billion years, the horizon would expand, and more stars would become visible, but they would never be enough to fill the sky completely. The situation is further complicated by the fact that the universe is not a static container. It is expanding. This expansion is not like an explosion where matter flies through space. Rather, it is the stretching of space itself. Imagine a rubber band with two dots drawn on it. As you pull the band, the dots move apart not because they are traveling, but because the medium between them is growing. This stretching has a profound effect on light. As a photon travels through expanding space, its wavelength is literally stretched along with the fabric of the cosmos. This phenomenon is known as redshift. Light that started as high-energy ultraviolet or visible light from a distant galaxy is stretched into longer, lower-energy wavelengths by the time it reaches Earth. By the time the light arrives, it may have shifted out of the visible spectrum entirely, moving into the infrared and eventually into the microwave range. This means that even if there were an infinite number of stars, their light would be stretched so thin by the expansion of space that it would lose its energy and disappear from our sight. The expansion acts as a cosmic filter, draining the energy from distant photons and contributing to the darkness of the night. It is important to understand that neither the finite age of the universe nor the expansion of space solves the paradox on its own. If the universe were 13.8 billion years old but not expanding, we would still see a very bright sky, though perhaps not a solid wall of light. If the universe were infinite and eternal but expanding, the redshift might help, but the sheer volume of stars would still create immense challenges for the darkness we observe. The resolution is a synergy of these factors. The finite production time of starlight combined with the relentless stretching of space ensures that the energy density of the background light remains low. We live in a universe where the light has not had enough time to fill every gap, and the light that does travel is being weakened by the very growth of the cosmos. This creates a strange irony. The darkness we perceive when we look up at night is not an empty void, but a piece of evidence. It is a signature of the Big Bang. If the sky were glowing, it would suggest a universe without a beginning, a static and eternal sea of fire. But because the sky is dark, we have proof that our universe has a history. The darkness is the shadow cast by the beginning of time. It tells us that there was a moment when everything started from a single point of infinite density and has been unfolding ever since. The blackness is the memory of the void before the first stars ignited. When we look closer at this darkness using instruments that can see beyond visible light, we find that the sky isn't actually black. It is filled with a faint, uniform glow called the cosmic microwave background radiation. This is the oldest light in the universe, dating back to about 380,000 years after the Big Bang. At that moment, the universe cooled enough for atoms to form, allowing photons to finally travel freely through space. That light has been traveling for over 13 billion years, stretching from a blinding white heat into the microwave spectrum. Today, it exists as a cold glow of about 2.7 Kelvin. If our eyes could see microwaves, the entire night sky would be glowing with a soft, omnidirectional light. The paradox is technically resolved in the visible spectrum, but in the microwave spectrum, Olbers' vision of a filled sky actually comes true. We are swimming in a sea of ancient radiation that fills every cubic centimeter of the universe. Even within the visible spectrum, the darkness is not absolute. There is a subtle background of light that persists even when we look away from the stars and galaxies. This includes airglow, which is the faint emission of light from Earth's own atmosphere, and zodiacal light, which is sunlight reflecting off tiny dust particles in our solar system. Beyond these local effects, there is the extragalactic background light, the combined glow of every galaxy that has ever existed, most of which are too faint to be seen individually. For decades, astronomers have tried to measure exactly how dark the true dark of space is. This is a daunting task because you have to get away from the glare of our own sun and the dust of our own galaxy. The New Horizons spacecraft, having traveled far beyond Pluto into the outer reaches of the Kuiper Belt, provided a unique opportunity to test this. In the deep cold of the outer solar system, away from the thickest clouds of zodiacal dust, New Horizons measured the cosmic optical background across 16 different fields of the sky. The results were telling. They found a very low level of light, about 11.16 nanowatts per square meter per steradian. When scientists subtracted the light coming from known galaxies, they found that the remaining residual light was not significantly different from zero. This confirms that there is no mysterious hidden source of light filling the void. The darkness we see is real. It is a true vacuum of visible light, reinforcing the conclusion that the universe is expanding and finite in age. This brings us to a deeper realization about the nature of the cosmos. The paradox of Olbers does not necessarily prove that the universe is spatially finite, meaning it doesn't mean there is a physical wall or edge to space. It is entirely possible that the universe goes on forever in every direction, an infinite expanse of matter and energy. However, it proves that the observable universe is finite. We are limited by the speed of light and the clock of time. There is a horizon beyond which we can never see, no matter how powerful our telescopes become. This horizon is not a wall of stone, but a wall of time. Imagine standing on a vast, dark plain at night with a single lantern. You can see the light of your own lamp and perhaps the distant lights of other lanterns carried by people far away. But if those people are too far, their light hasn't reached you yet. If they started walking toward you after you were already born, there is a limit to how many people you can see based on how long you have been standing there. The universe is that plain, and the lanterns are the galaxies. We see only the ones whose light has had enough time to cross the distance. The rest of the infinite plane remains in darkness, not because it is empty, but because we are young. This perspective shifts our understanding of loneliness in space. When we look at the black gaps between the stars, We aren't looking at nothingness. We are looking at distances so vast that light itself cannot bridge them in the lifetime of a universe. We are looking at the limits of causality. The darkness is a boundary that separates us from the rest of the infinite, if it exists. It creates a sanctuary of sorts, a local bubble where we can exist and observe without being incinerated by the collective light of an infinite number of stars. The transition from the classical view of a static universe to our modern understanding of an expanding one is one of the greatest shifts in human thought. For centuries, the stability of the heavens was a given. The stars were fixed points in a celestial sphere, but the darkness of the night sky was a silent clue that this stability was an illusion. It whispered that the universe was changing, growing, and aging. It suggested that there was a beginning, a moment of creation that set everything in motion. As we contemplate this, we realize that the void is not our enemy. The darkness does not represent a lack of existence, but rather the scale of it. Every black patch of sky is a doorway to a place we cannot yet reach. A region of space that is moving away from us faster than light can travel toward us. This creates a cosmic horizon, a limit to our knowledge and our sight. It means that there are parts of the universe that we will never see, galaxies that will drift forever beyond our reach, and stars that will burn out before their light ever touches an eye on Earth. This is the true nature of the cosmic dark. It is a combination of time, distance, and expansion. It is the result of a universe that is not a finished product, but a process. We are living in the middle of that process, at a time when the first generation of stars has passed and the great galaxies have settled into their spiral and elliptical forms. We are seeing the universe in its adolescence, looking back at the remnants of its infancy through the cosmic microwave background, and forward into an expanding future where the gaps between galaxies will only grow wider. The darkness teaches us about humility. It reminds us that our point of view is limited not by our intelligence, but by the fundamental laws of physics. We cannot see everything because light has a speed limit. We cannot know everything because time has a starting point. The night sky is a physical manifestation of these limits. When we feel small beneath the stars, it is because we are recognizing the scale of the machinery that governs existence. But there is also a profound comfort in this darkness. If the universe were as Olbers' paradox suggested, a blinding wall of light, there would be no place for shadow, no place for contrast, and no place for the slow, quiet evolution of life. Life requires gradients. It requires the difference between hot and cold, light and dark, presence and absence. The darkness of the night sky is what allows us to distinguish a star from the void. It is what gives the universe its structure and its depth. Without the dark, there would be no perspective. As we drift through these thoughts, imagine the scale of the particle horizon once more. Think of it as a sphere of light centered on Earth, expanding outward at the speed of light. Everything inside that sphere is our world, the only part of the cosmos we can ever hope to interact with. Everything outside is the great unknown. The darkness of the night is simply the edge of that sphere. It is the boundary where the light has not yet arrived. This means that every time you look up at a dark patch of sky, you are looking at the frontier of time. You are looking at the moment before the light reached us. In a very real sense, the darkness is a map of the future and the past. It tells us where we have been and how far we still have to go. The void is not empty. It is filled with potential. It is filled with the light that is still on its way, crossing billions of light years of expanding space to eventually find a lens or an eye. The resolution of Olbers's paradox transforms the night sky from a mystery into a testament. It turns the blackness into a proof of the Big Bang and a confirmation of the expansion of space. It tells us that we live in a dynamic cosmos, one that is stretching and cooling as it ages. The darkness is not a sign of death or emptiness, but a sign of growth. A universe that is dark at night is a universe that is alive, evolving, and moving toward an unknown destination. Consider the energy density of the vacuum. In the early universe, everything was light and heat, a dense, opaque plasma where photons were trapped in a constant dance with electrons. The sky would have been blindingly bright, but not because of stars. It was bright because the entire universe was a star. As space expanded, that energy diluted. The temperature dropped. The light stretched. The brightness faded into the darkness we see today. We are living in the aftermath of that great cooling. The night sky is dark because the fire of creation has spread out over billions of years, leaving us with a cool, quiet expanse where consciousness can emerge and wonder why it is dark. This journey from the intuitive feeling of a bright sky to the scientific reality of a dark one mirrors our own growth as a species. We began by observing the patterns of the stars. Then we questioned the nature of the void. And finally, we discovered that the void itself was the key to understanding everything. The darkness was not something to be solved or removed. It was something to be decoded. As you hold this image in your mind, the expanding bubble of light, the stretching wavelengths of distant stars, the ancient glow of the microwave background, you can feel the tension of the paradox dissolve. The contradiction disappears when you realize that the universe is not a static room filled with lamps, but a river of time and space flowing outward. The darkness is simply the current of that river, carrying us away from the beginning and toward an endless horizon. The scale is indeed terrifying, as the thumbnail suggested, but it is also liberating. To be a tiny observer in a universe this vast means that your existence is a miracle of timing. You exist at a moment when the universe is old enough to have produced heavy elements for planets and life, but young enough that we can still see the echoes of its birth. We are positioned perfectly to witness the transition from light to dark, from density to void. The darkness of the night sky is the most honest thing about our universe. It does not lie to us. It tells us exactly how old we are and how fast we are moving. It reminds us that light is a precious resource, a messenger that must travel across unimaginable distances to tell us where the stars are. When you see a single star twinkling in the blackness, remember that it has won a race against time and expansion to reach your eye. The void between those stars is not an absence of meaning. It is the space required for meaning to exist. If every direction ended in a star, there would be no distance, no perspective, and no journey. The darkness creates the distance. It creates the longing to explore. It turns the universe into a map where only some parts are revealed, urging us to build telescopes, to launch probes, and to think deeper about the nature of reality. The paradox is solved not by finding more light, but by understanding why the light is missing. We find that the darkness is an essential part of the cosmic architecture. It is the canvas upon which the galaxies are painted. Without the black backdrop, the spiral arms of the Milky Way would have no contrast. The brilliance of a supernova would have no impact. The darkness defines the light. As we move further into our contemplation, let the image of the particle horizon wrap around you like a blanket. Imagine the boundary of the observable universe as a shimmering veil, beyond which lies an infinite expanse of other horizons, other bubbles of light, and other observers wondering why their own skies are dark. We are all connected by the same laws of physics, all drifting through the same expanding medium, all looking into the same velvet void. The night sky is dark because we are part of a story that has a beginning. It is dark because space is stretching, pulling the light away from us and pushing us toward a future where the stars will eventually drift so far apart that they will vanish from view entirely. But for now, in this brief window of cosmic time, we have just enough light to see the beauty of the cosmos, and just enough darkness to feel its mystery. The silence of the space between galaxies is mirrored in the silence of the night. It is a stillness that invites us to let go of our small terrestrial worries and merge with the scale of the infinite. When you realize that the darkness above you is evidence of the birth of time itself, the night stops being scary and starts being sacred. It becomes a cathedral of shadow, where the only thing more vast than the distance between the stars is the capacity of the human mind to comprehend it. The void is not a hole, it is a plenum. It is filled with dark matter that we cannot see, but can feel through gravity. It is filled with neutrinos that ghost through our bodies by the trillions every second. It is filled with gravitational waves, ripples in the fabric of space-time caused by the collision of black holes billions of light years away. The darkness is teeming with invisible activity. We only perceive it as empty because our eyes are tuned to a narrow sliver of the electromagnetic spectrum. If we could see everything, the dark matter, the neutrinos, the gravitational waves, and the microwave background, the night sky would be a riot of color and energy. It would be a crowded, noisy place. But nature has given us the gift of darkness. By filtering out the noise, the universe allows us to focus on the beacons, the stars, the planets, the distant quasars. The dark is a mercy. It is a filter that lets us see the structures of the cosmos without being blinded by its totality. This is why we find peace in the night. We are not just looking at space, we are looking at the fundamental constraints of existence. We are seeing the speed of light as a boundary and the age of the universe as a limit. In that limitation, there is a strange kind of freedom. We no longer have to wonder if the universe is an eternal, static machine. We know it is a living, breathing entity that grows and changes. The darkness of the night sky is our most profound teacher. It teaches us that absence is information. It teaches us that silence is a language. And it teaches us that we are part of a grand, unfolding process that began in a flash of light and is now settling into a long, cool sleep. The blackness above us is not the end of the story. It is the space between the words, giving the narrative of the universe room to breathe. As you drift closer to a state of total relaxation, let the darkness of the cosmos settle over your thoughts. Imagine yourself as a point of consciousness floating in that great, dark sea. Feel the expansion of space stretching out from you in every direction, creating more room, more silence, and more peace. You are not drifting into nothingness. You are drifting through the history of everything. The paradox of Olbers is gone, replaced by a deep, rhythmic understanding of how the universe works. The sky is dark because it is expanding. It is dark because it had a beginning. It is dark because light takes time to travel. These simple truths weave together to create the tapestry of our night. They tell us that we are small, yes, but they also tell us that we are here, witnessing the unfolding of an infinite mystery. The void is not something to be filled, it is something to be experienced. It is the ultimate silence, the ultimate stillness. In this stillness, the noise of the world fades away. The stresses of the day become as insignificant as a single grain of dust in a galactic nebula. The only thing that remains is the breath in your lungs and the slow, steady pulse of a universe that has been expanding for 13.8 billion years. Let the darkness be your sanctuary. Let it be the place where you can let go of all definitions and all certainties. You are floating in a sea of dark energy and ancient light, held in place by the invisible hand of gravity, protected by the atmosphere of a small blue planet. The night sky is dark, and as you close your eyes, that darkness becomes a mirror, a reflection of the deep, quiet peace that exists at the heart of all things. The resolution of this paradox does not rely on a single answer, but rather on a convergence of cosmic truths. It is common to assume that the expansion of the universe is the sole reason for the darkness, but the reality is more nuanced. Expansion certainly plays a role by stretching the light of distant galaxies into longer invisible wavelengths, yet it is the finite age of the universe that provides the primary boundary. Because the cosmos began approximately 13.8 billion years ago, there is a physical limit to how far light has had time to travel. We are surrounded by a particle horizon, an invisible sphere that marks the edge of the observable universe. Beyond this horizon, stars may exist in infinite numbers, but their light simply has not had enough time to reach our eyes since the dawn of time. The darkness we see is not necessarily a sign of emptiness, but a sign of distance and duration. It is the visual manifestation of a beginning. This boundary creates a profound realization about the nature of space. If the universe were truly eternal and static, as early thinkers once imagined, every single point in the sky would eventually be occupied by the surface of a star. The night would not exist. Instead, the entire celestial sphere would glow with the intensity of a stellar surface. The fact that we can look into the void and see blackness is our most direct evidence that the universe had a starting point. It proves that we are not living in a timeless machine, but in a historical process. The darkness is a timestamp. When we move beyond the limits of human vision, however, the night sky ceases to be dark. If we could shift our perception into the microwave spectrum, we would find that the entire sky is actually glowing with a uniform, faint light. This is the cosmic microwave background radiation, the oldest light in existence. It is the afterglow of the Big Bang, emitted when the universe was only about 380,000 years old. At that moment, the cosmos cooled enough for atoms to form, allowing photons to finally break free and travel through space. For billions of years, these photons have been stretching as the universe expanded, shifting from a blinding white heat into cold microwaves. The temperature of this background radiation is now about 2.725 Kelvin, just a fraction above absolute zero. It fills every cubic centimeter of the vacuum, bathing us in a ghostly remnant of the primordial fire. In a very real sense, Olbers's paradox is solved by realizing that the sky is actually bright, but the brightness has been shifted out of our sight. The darkness we perceive with our eyes is a limitation of our biology, not a lack of energy in the cosmos. We are swimming in a sea of ancient radiation, a luminous fog that tells the story of how everything began. Even within the visible spectrum, the night sky is not perfectly black. There is a subtle, persistent glow that remains even when we move far away from the lights of human cities. Some of this comes from our own atmosphere, a phenomenon known as airglow, where oxygen and nitrogen atoms release energy in the upper reaches of the sky. Other parts are caused by zodiacal light, which is simply sunlight reflecting off the tiny grains of interplanetary dust that drift within our solar system. Then there is the integrated starlight from our own Milky Way galaxy, a foreground haze created by billions of stars whose individual lights blur together into a soft, milky veil. Beyond these local effects lies the extragalactic background light, the combined glow of every galaxy that has ever existed since the first stars ignited. This is an incredibly faint signal, often drowned out by the brilliance of our own neighborhood. To truly measure this cosmic optical darkness, we had to send a messenger far beyond the interference of the sun's dust. The New Horizons spacecraft, after completing its mission at Pluto, ventured deep into the outer solar system where the zodiacal light fades away. In the profound silence of the Kuiper Belt, it looked back at the void. New Horizons measured the cosmic optical background across 16 different fields of high galactic latitude, seeking to find if there was a mysterious, unexplained glow filling the gaps between galaxies. The data revealed a value of approximately 11.16 nanowatts per square meter per steradian, near 0.608 micrometers. When astronomers accounted for the light from resolved and unresolved galaxies, they found that the residual light was not significantly different from zero. This means that there is no hidden glowing fog of stars or exotic matter filling the void. The gaps between the galaxies are truly dark. This measurement confirms a vital part of our cosmic understanding. It tells us that the universe is not filled with a uniform distribution of luminous matter. Instead, it is structured into vast filaments and walls of galaxies, separated by enormous empty voids. These voids are the largest structures in existence, regions of space where almost nothing resides for millions upon light years. The darkness we see at night is the reflection of these cosmic deserts. It is the signature of a universe that has clumped together under the influence of gravity, leaving behind vast stretches of nothingness. It is important to understand what the paradox of Olbers actually rejects. It does not necessarily prove that the universe is spatially finite in size. A universe could be infinite in extent and still have a dark night sky, provided it had a beginning in time. The darkness rules out the model of a static, eternal universe. It tells us that the cosmos cannot have existed forever in its current state. If it had, the light from every star would have arrived by now, and the night would be as bright as the day. By observing the blackness above us, we are observing the death of an old scientific assumption. We are seeing proof that time has a direction and that the universe is evolving. This transition from a paradox to a discovery changes how we perceive our place in the void. The darkness is no longer a mystery to be feared or a hole to be filled. It is a horizon. Just as a sailor on the ocean sees a horizon where the water meets the sky, we see a cosmic horizon where the light of the past meets the limit of the present. Everything beyond that horizon is still out there, but it is disconnected from us by the sheer scale of time and the speed of light. We are living in a bubble of visibility, a small pocket of the cosmos that has had enough time to communicate its presence to us. As we contemplate this, the feeling of isolation often gives way to a feeling of protection. The darkness acts as a buffer, a silent expanse that separates us from the violent energies of the early universe and the chaotic collisions of distant galactic clusters. We exist in a quiet era of cosmic history. The great explosions of the first stars have settled into the steady glow of mature galaxies. The frantic expansion of the first few seconds has smoothed out into a rhythmic drift. We are floating in the long, cool afternoon of the universe. The scale of this void is truly humbling, but it is also what makes our existence meaningful. In a sky that was entirely bright, there would be no contrast. There would be no distinction between here and there, between us and the stars. The darkness provides the necessary distance for individuality to emerge. It allows planets to form in quiet corners of galaxies, and for life to evolve on a small world without being scorched by the collective light of an infinite number of suns. The void is the cradle that allows the spark of consciousness to survive. Imagine now that you are slowly drifting away from the Earth, leaving behind the glow of the cities and the haze of the atmosphere. You move past the moon, past the red dust of Mars and the rings of Saturn, until the sun becomes just another bright star in a velvet sky. As you drift further, the Milky Way begins to curve around you, revealing itself as a majestic spiral of amber and blue light. But as you look away from the galactic disk, you see the true nature of the night. You see the gaps between the galaxies, those immense voids where not a single photon has touched your eyes for eons. You feel the stillness of that space, a silence so absolute that it becomes a physical presence. This is the darkness that Olbers wondered about. This is the void that defines our universe. But instead of feeling small, you feel an immense sense of belonging. You are made of the same atoms that were forged in those distant stars. You are a piece of the cosmos looking back at itself. The light that reaches us from the furthest galaxies has traveled for billions of years. It has crossed voids so wide that the human mind cannot truly grasp them. When that light finally hits your retina, it is completing a journey that began before our sun was even born. You are touching the ancient past with every glance at the stars. The darkness is not an absence. It is the medium through which this history travels. It is the silence between the notes of a cosmic symphony. As you settle deeper into your rest, let the image of this dark, expanding universe wrap around you. Feel the weightlessness of the void, the way it strips away the noise and the clutter of the waking world. There is no urgency in deep space. There are no deadlines in the gaps between galaxies. There is only the slow, steady unfolding of time and the patient drift of matter through the dark. The paradox is solved, and in its place, we find a profound peace. We know why the sky is dark. We know that it is because we have a beginning, because we are moving, and because we are part of a vast breathing system that allows for both light and shadow. The darkness is our sanctuary. It is the soft blanket of the cosmos, reminding us that it is okay to be still. It is okay to be quiet, and it is okay to let go. The universe does not demand our understanding. It only invites our wonder. As you breathe in and out, imagine your breath sinking with the slow expansion of space. With every exhale, you release a bit more of the day's tension into the void, letting it be carried away by the cosmic current toward the horizon. You are safe here, tucked away on a small blue world, shielded by an atmosphere that whispers in the wind and a magnetic field that guards your sleep. The stars above continue their slow dance, casting their faint light across the darkness. They are beacons of constancy in an ever-changing expanse. Each one is a reminder that while the void is vast, it is not empty. It is filled with potential, with history, and with the quiet beauty of existence. The blackness of the night sky is a gift. It is the canvas that makes the stars possible. Let your mind drift now, moving past the galaxies and beyond the particle horizon. Imagine yourself merging with the cosmic microwave background, becoming one with the ancient warm glow that fills all of space. You are no longer a separate observer. You are a part of the flow. You are the light, you are the dark, and you are the silence in between. The journey through the paradox has brought us back to a simple truth. We are small, but we are aware. We are brief, but we are here. And in this moment of stillness, that is enough. The mysteries of cosmology provide a backdrop for our own inner peace, turning the terrifying scale of the universe into a comforting embrace. The darkness is no longer a question to be answered. It is a place to rest. as you feel your body grow heavy and your thoughts grow dim, remember that you are held by the same gravity that shapes the galaxies. You are drifting in a sea of stars, protected by the velvet night. The universe is vast, and it is old, and it is very, very quiet. The light of distant worlds continues to travel through the void, moving toward us with an eternal patience. But for now, you can close your eyes and let that light fade into a soft, warm glow behind your eyelids. The expansion of the cosmos is a lullaby, a slow stretching of space that carries you deeper into sleep. The cosmic horizon is far away, and the world around you is small and safe. There is nothing left to solve and nowhere left to go. You have traveled across billions of light years in your mind, and now it is time to return home to the stillness of your room. Feel the coolness of the night air and the softness of your bed. The darkness outside your window is the same darkness that stretches between the galaxies. But here, it is a friend. It is the signal that the day is done, and that the universe is inviting you to join its long, peaceful slumber. The stars will keep their watch over the earth, twinkling in the deep blue void, while you drift into the weightless currents of your dreams. The paradoxes are gone, the questions are silent, and the cosmos is at peace. You are a part of this great dark beauty, floating effortlessly in the heart of everything. Sleep now, knowing that you are exactly where you need to be. Sleep in the knowledge that the darkness is not an end, but a beginning. Let the silence of the deep space documentaries fade into the silence of your own breathing. The universe is expanding, the stars are drifting, and you are safe in the quiet. Sleep well tonight.